If any of you have been catching the webinars that Jay and I have been hosting, or being the background hosts for on Efficiency First, we've been trying to get more conversation going through a webinar versus giving you a bunch of polls. So instead of stopping, we all wait for the minute to go by for the poll. We just been trying to ask more questions as we go and get more feedback from you. So if you could help us with that, that'd be a lot easier to do than trying to add a bunch of polls. So today we're going to talk about some performing test options. Should I test or not? Should I stay or should I go? Should I test or not? What are some suspect conditions? And reducing your liability through your basic knowledge as to having better discussions, trying to be more observant about some of the details that are in these homes, and having a plan of action when you find them. So first question out there for everybody: what type of gauge or equipment do you have? You could say both. We'd understand that means you'd have both Retrotec and Energy Conservatory, or I mostly have Retrotec, and I usually use which gauge, so that gives me some information. Or you can say I have a TEC or the DG 700. Some of the things I'm talking about are specific to Retrotec, but I do have things with both. So when I have a lot of Energy Conservatory folks out there, I try to make sure that I include the conversation fully as best as I can. So great, excellent feedback, people. We appreciate that a lot. Okay, so many of you come to these webinars and you hear Jay and I talk, and this is a Retrotec webinar, but I'm going to reiterate that Jay and I do not work directly from them, and you may think that's kind of strange because we're very active with them, and they're my main client, but my company is Energy Environmental Consulting. And I have a retainer to develop curriculum and do webinars and do product development and do a variety of stuff for them. So many times I represent Retrotec, but I want to make sure it's clear that today the things that I'm actually stating about health environments, environmental conditions are not the views of Retrotec, and I'll explain why you should clarify that whenever you have the chance also. So these are some of my credentials, and at the bottom I used to live another life, which was as an IAQ professional, dealing with a lot of these same issues, and many of those were way before lead became a certified practice. So I thought that was good. So if there's one slide that I really would want you to memorize or keep track of or do something with, and that is, it's this slide. And I actually have a little piece of cardboard that I printed out that's right above my computer that says this exact sentence. It says, be the source of the source. When I first started doing home inspections in IAQ, my mentor made it very clear that when somebody says that this is how it should be or this is the corrective action, that it should never sound like I'm the person creating those solutions, that I'm not the source of you should do A, B, and C, that you should be quoting the source. And so I highly recommend you make sure if you're ever going to give information or advice in your reports or in general verbally, that you explain where that came from, that they don't feel as though you're the one describing the solution for them. These are the most common resources and references that are out there. There's numerous ones, but these are some of the most common ones that you would go to for many of these conditions. So the EPA, the CDC, ASTDR is one that some people may be familiar with, but it's more about the toxic substances, including dealing with asbestos. And one that's kind of new to a lot of people, it's called EDR.net. And if you really want to check out something that may help your conditions for those of you that may be doing semi-environmental or have issues that you're trying to solve for folks, then this actually does a, also just thought of in the commercial thing as a an area evaluation in terms of what kind of conditions are around this home. Like, was there a lead paint distribution source, less than a mile away, that's no longer there? They keep track of all the different things that are environmental impacts due to property locations. Yes, somebody did point out that Luke is the source, so we can all wait for the next version of Star Wars to confirm that. So one of the things I preach regularly about is liability, and trying to make sure that you're not the person that is fully liable for anything you do in the house. So in general, most people that are doing home performance and audit or energy, your liability is really fairly low. You know, when you say that I'm going to reduce your energy bills or something, that kind of puts you into liability, but most people aren't getting sued because they didn't save as much money as you promised. But when you go in and you say you have mold on the wall, or you say, oh, that's asbestos, or you say things that are beyond your credentials, that will get you in a lot of trouble. And you want to be very cautious about what it is you say or stay within your training. Even though it may be obvious to all of us what that fuzzy stuff is on the wall in the bathroom, we're going to talk about mold briefly and why it is that you cannot say that it's mold. There is an entire industry of lawyers that focus on this stuff specifically about going after people who misrepresent themselves, or a lot of things where people that were telling people it's mold, I need this, you need to give me 20 grand to fix your house, when that really wasn't the case. So they're very cautious about people that touch on these situations. And now with the new Healthy Home Evaluator credential that BPI has, this whole healthy home concept has really entered the auditor's realm and will become much more common and popular, that we're being much more sensitive to these kind of issues, from rodent droppings to cockroaches or other stuff that we may have not thought twice about when we do an audit. So these kind of things are something you definitely want to be paying attention to. I highly encourage you to pay attention to what BPI is doing with their Healthy Home Evaluator and the training that'll probably be out within a couple of months. You can actually take the test now in terms of a pre-test or evaluating it. One of the things at the bottom here is I commonly get calls and be like, hey, Joe, we're thinking about adding mold testing to our services so we won't get sued. And I'm like, well, it doesn't matter if you're certified or not. If you go into a house that has these things, you have the potential of being sued. So best thing you could do is be knowledgeable about the conditions and know how to identify them, and make sure you're able to send people to the right source. So here's one that you may or may not have. A lot of folks may be weatherization folks, and you should have this in your company-wide system. But if not, if you're a smaller company, I was an individual guy for a long time, and I created a simple operating hazardous procedure. So if I saw these things, it said that I would do this, and I will give the homeowner these documents and make sure they get an email with such and such information with links. That allowed me to, if there ever was an issue and somebody says, well, what's your procedure if you find that which may be mold or some type of asbestos, I can say, boom, here's my procedure when I have some type of suspect condition. So if you don't have something like this, it's not that difficult to put together something. Even any procedure that may seem out of date is better than no procedure at all. So I highly encourage you to make sure you create something like this, even if it's just an email that has links to the EPA and CDC about some of these things if you suspect they're there. So one of the things you want to be clued into, and if you probably already are, is 1978 was the number. In general, in the industry, we kind of think about 1980, that things that are before that. So if you're working in homes that are prior to 1980, you've already got, or really technically 78 if you really want to be there. But whether or not you have lead conditions, asbestos conditions, a variety of stuff was in that pre-80 concept. So we're going to talk about some issues with asbestos and friable and other stuff on here in definitions. But in general, if you're working in these kind of older homes, you should assume that they are these kinds of conditions. I know some people that are lead conscious realize, well, I don't know if I don't test, but prior to 78, depends on how obvious it is. Those are kind of things that kind of get you in trouble. Ignorance is never an excuse when you get sued. So let's talk about your standard audit. So if there's something that's not on this list, please throw that out for us. So I'm assuming that most people that do an audit may do all of these, some of these, or at least a few of these for sure. So most people are doing a blower door test and you're depressurizing, right? Most people are doing a duct test. Many times it's just a total leakage test, and that may or may not happen, depends on the home or your assessment. That's not that common in weatherization. Depends on your area, right? Many people are doing the CAS test. Some people are doing the CFM typo in the exhaust fans. Some people have doing the IR. So all these things are things that many people are doing. So there's something else not on the list that you're doing, like, oh, I definitely should add that to the list. Let me know what they are. And now we're going to talk about if you're going to do a home where you do know there's suspect conditions or potential issues maybe, or the Healthy Home Evaluator. So this is the list that I tried to alter to do that. So Whether or not you do a blower door or duct test is going to be the questions that we're going to be evaluating. But you still can do and should be doing a carbon monoxide and CAS test. You definitely want to be testing the CFM flows and exhaust fans. And those are really for especially areas that have like homes that have high moisture issues. So if you're, one of the reasons that the Healthy Home Evaluator has joined forces with the Energy Auditor is because we're very knowledgeable about the building science. So a lot of IAQ professionals out there struggle with finding the source or the cause or what are the problems. They don't realize that your HVAC system can be a major source or cause of some of the pollutants issue or moisture in your house. And that's not something that they're really familiar with on a day-to-day basis. So it isn't always a leaky roof that's causing high moisture in a house. So that's why you want to make sure you're testing the exhaust fans due to the moisture levels that you also will be measuring as you look at the bottom line. Zonal pressure diagnostics, that can be done without a blower door in terms of what kind of pressures are happening throughout the house or no pressures. And it can also be done by pressurizing the house versus depressurization. Dominant duct leakage test, we're going to talk about what some of these other ones are that may or may not you be doing. I actually got illustrations on these. So the one that you definitely want to start be doing in terms of just in general is making sure there's no extreme temperature differences throughout the house. Relative humidity and AH is absolute humidity. Those are the kind of measurements that people are taking when they're evaluating homes that have suspect conditions, or if people are sensitive to those kind of conditions, or if you're doing a healthy home environment assessment. These are some of the tests you'll be doing as a general assessment, and then decide whether or not you can do more of the blower door or duct tests. Hopefully that was clear. Okay, so are you asking these questions to your occupants? And if you are not, I highly encourage you to make sure you put it on a piece of paper and get them to answer it or a reminder, because these are the last thing you want to do is do a blower door test or even a duct test and forgot to have asked these questions, all right? So do you or anyone in the house have asthma or breathing sensitivities or any kind of issues that I should be aware of, or any recent moisture damage or other repairs, or just any concerns that they may have that are medical or about the home itself? And I know you may ask general questions about why you're there for energy issues or what home has it's hot or cold, but you definitely want to make sure you're addressing these. And you may not be after doing healthy home evaluation, but you definitely want to make sure that you're not going to cause any issues that would make them uncomfortable or cause any kind of problems. And we're going to learn that asthma is a significant issue in the U.S. in general, and what can happen if you actually stir up a bunch of conditions in the house that could cause an asthma attack. All right, so should you perform the blower door test or duct test? So it's really, there is no hard fast rule, and I'll go through a variety of suspect conditions, and I cannot answer it for you. And I've done this live, and some people are like, every home I go into, all of the ducts are wrapped with asbestos, and it is impossible for me to not test. And that's something that they decided as a company and as a tester on what they're going to do. Many of us may only find that we have a few homes that we show up and these conditions are occurring, versus knowing that every home I go into has vermiculite in the attic. What should I do? So if you have this every day in your life, you probably have already assessed a situation, but you definitely make sure you're giving information again to the client about that. So BPI and similar certifying bodies do have guidance, but the guidance is to generally say do no harm. So if you find conditions, it is really your judgment call as to how much of an impact the tests you're doing will be on the structure itself and the occupants. So again, there are no hard fast rules. So for those of you that want to fade away from the webinar, I totally understand that, but the reality is you are the person who makes these decisions, and obviously makes these decisions with your client or informing your client. So that's one of the greatest things you can do, is make sure that you're informed, and the decision sometimes can come from the client, that you explain to them what this is. It looks like you may have asbestos wrap on your ducts. It's not something I can comfortably test without discussing with you, or maybe you have it tested and they're like, I've been lived that way forever. It's okay, Joe, go ahead and test that. And then I actually have their permission and make sure I document that. But your goal is to make sure that you're not making decisions for your homeowner without their knowledge. Okay, so I even put this slide up whenever I even talk about code compliance, that you could never know when the crawl space was flooded or some weird thing happened in the attic. That do you, before you turn on that blower door, are you fully evaluating the crawl space, attic, kind of the duct system, and the garage before you test? Because there could be something growing in the attic that you want to make sure you are not pulling into the space or the crawl space. It's not uncommon to see standing water in a crawl space and you've already did your blower door test and not really sure what kind of stuff you may have brought into that, because there's definitely connections between these kinds of homes, especially the older homes. So you definitely want to make sure you're not just peeking your head into the attic, but you actually do that part of your evaluation. Same with the crawl space. Okay, so we're going to talk about some pressurization and different tests real quick. So if anybody has any questions, throw those out. I'll try and integrate them. And I do have stuff about suspect conditions after we do the test. I want to make sure we cover some of the technical stuff about testing first. So this is the standard test. Again, this is Retrotec equipment. Many of you that have the equipment, you understand the concept of setting this stuff up. But we're inside the house for all of our illustrations, and we're depressurizing right now. So we're actually pulling air out of the home and measuring that as our test. So one of the differences, and again, this is a little more detailed illustration we're going to go through, so we make sure we understand the tubing for Retrotec, and I have Energy Conservatory set up on here. So again, we're depressurizing the envelope. If you really want to keep track of one thing, if you're using Retrotec, and it doesn't matter where you're standing, you could even be outside doing the same test. You could be pressurizing. It doesn't matter where you're standing or which way the fan is going. The red tube always goes through the red cloth. And for their standard residential 1,000, 3,000 blower doors, there's no additional tubing to add. The only thing you do is make sure the red tube goes through the red cloth, and you can test wherever you're standing. So that's their, everybody has their rule of thumb. Energy Conservatory has green to grass. Retrotec has red tubes through the red cloth all day long.
So Joe,
yeah,
I just want to make sure that that's clear. That if you want to depressurize or pressurize, then you're on the inside of the cloth or the outside of the cloth. That essentially the tubing is going to be the same whether you're depressurizing or pressurizing. So there's nothing to change. You just flip the fan around. That's it.
That's fine. But you could be, that's right. You flip the fan around and pressurize or depressurize, and you could be inside or outside. And it's also meaning that wherever you're at is also the gauge. So I'm holding the gauge when I do this test. So red cloth, red tube through the red cloth. Thanks, Jay. All right, let's go to our next slide. Okay, so now when I am pressurizing the house, so now I've actually flipped the fan around. Is that right? Make sure, yeah, okay, good. So here we're depressurizing. 2 slides went by. And now we're going to pressurize. So in general, most of the times we're going to be standing in the house when we do these tests. But I just want to make sure it was clear that you understood the tubing setup for the Retrotec system. So we're inside the house, and we're going to pressurize. So basically, I'm just going to flip the fan around, right, knowing that my rings are on the outside, because I still may want to go to a specific pressure. So, and I'm not going to depressurize to find out what my ranges are. So if I have to change the ranges, I got to stop the fan and flip it back around. So I'm now bringing air into the house to do this kind of test. And there'll be a couple of reasons why later we talk about suspect conditions that are on the outside of the house that I may decide to pressurize the house so I don't accidentally bring in contaminants. So that's why we're going through these scenarios. So when we're pressurizing the house, again, the tubing did not change. I just merely turned the fan around. So there's a couple of things that are between pressurization versus depressurization. All right, many of the times we're pressurizing. So one of my questions is that why are you doing a blower door at all? I mean, what are you measuring? Is it for compliance? Is it for a number that you're going to do a test in and test out? Let's say we do have homes that may have suspect conditions, or somebody says that they have a potential asthma issue. That person may not be home, or for whatever reasons they agree that it's okay for you to do a blower door test. You don't always have to go to 50 pascals. Your goal is to try to get to a number, many times just to find leaks in the house, right? And you want to seal them. So unless you must get a CFM number at 50 pascals for whatever purpose that is, then you have alternatives that you should be thinking about in terms of what pressure do I really need to test to, how much impact do I need to put on this home, and whether I pressurize or depressurize. So one of the things that is different, and of course you're going to document all those things, so maybe you only do a blower door test that goes to 25 pascals. But I easily can go around the house and find lots of leaks or issues with a much lower pressure if that's all I want to do is focus on air sealing in the house. So the one difference is that when I depressurize, all of the dampers, all of the dampers are staying closed. So we'll go back one slide. Oh, my damper didn't show up. So when I pressurize, all my dampers become open. That's really the bottom line there. So if you do one and do the other, you may find that your leakage is higher on pressurization because many of the dampers around the house have now been pushed open. There are several things you can still do with your pressurization tests. Okay, many things that we do are dealing with depressurization because that's normally how we do this test. So you can still do zonal pressure diagnostics. Your numbers, instead of being a positive number, just may be a negative number. But the ratio of numbers that are still on your gauge is still the same. So if you're only referencing the inside of the house and you have negative 50, then you're outside. Yeah, the closer you get to 0 means you're still inside. So it's the same concept, you just have a negative now in front of your results. But again, some people run the reference to outside. So there's different ways about zonal pressure diagnostics. So I want to make sure we're on the same path. We and I usually just I reference the inside of the house. I don't actually run an extra tube outside. So that can be done whether you're pressurizing or depressurizing. You can also measure the ducts to outdoors if you have a passive or powered flow hood. So those are the kind of things that are options for you. If you still want to do duct leakage, but you may have issues about whether or not you have asbestos, there's another alternative that I can actually do pressurize the house and measure it by using the flow hood. And we have examples of that also. So I also thought I would include the energy conservatory illustration just so we're on the same page. So if you are going to use a energy conservatory in your pressurizer, which means you turn the fan around, and this is because you want to measure it. Many of you that are out there, I know you probably have the fan that's got the switch on it. And you can use that just to find flows or leakage. You cannot flip the switch and do it to measure a CFM number, just so you're probably aware of that, but just if you buy a used fan, you can't just flip the switch and then measure CFM. So we've turned the fan around, and for energy conservatory, you're going to add an additional tube onto channel B on the reference on the bottom. So, and that's going to go outside. So that's the difference. Yes, Jay?
Oh, Joe, I just want to make sure that everybody understands why the flow ring, the white flow ring that points on the inside of the energy conservatory fan are where the flows are taken from. So if you simply switch the direction by using the switch on it, it's not going to be able to properly interpret the flows across that. So the point is that is the reason why you have to actually physically turn the fan around and then add those additional tubes. Just so everybody knows, because I know that the newest energy conservatory fans, they got rid of the switch because so many people made that mistake. So I just want to clarify that. Back to you, Joe.
Thank you, Jay. So again, now you can see them comparable. That Retrotec, I don't need to add anything. If I flip my fan around, energy conservatory, there's an extra tube to do that. And this, again, this is to measure your CFM if you needed to. Okay, so I'm going to do a next scenario, which is how to measure duct leakage with the blower door option, whether it's powered or passive. We're going to, I'll briefly talk about the difference between powered versus passive systems. So if my reading that the flow hood that I'm reading, all right, again, this is all same way you might measure exhaust fans. That's my flow, is it's actually going from the inside of the house to the outside. So we're going to do, again, we're talking about pressurizing the house, what other tests I can still do. So when I have a passive flow hood on the left, it just measures the air on its measurements, and the powered flow hood actually has a fan inside that will zero the pressure inside to equalize it and then give me the reading. So for measuring exhaust fans or exhaust type flows, both of them really just do a job that's very equal. If you're dealing with positive flows, things that are coming out of your supply ducts, then a powered flow hood is superior in terms of your readings. So Retrotec does have one that could be used for either of these purposes, either supply or return. If you're looking for more information, reach out in the chat window there, and Jay can send you some information. So here's one of the methods. This is really common in home performance. I know that it's not that common in weatherization or some audits. Some people really want to connect their duct tester, but even in Kentucky, this is an accepted method for code compliance, and that is that I'm pressurizing the house with my blower door. Again, we're doing this for multiple reasons, but again, it's probably due to suspect conditions. But I can also measure this. So most home performance contractors show up, they throw the blower door in, they pressurize the house, and they go around with their flow hood, and they can actually measure the flows. And this is flow that's going to the outside. So you can see the path of my air coming in, and as it moves through the flow hood, it moves through the duct into the outside. So this is not a total leakage. This is a leakage to outdoors type of a measurement. So I can actually go around and add up all of the measurements that I've got and get a total leakage to the outside using this method. And it's a lot easier sometimes than hooking up a duct tester to the whole system, sealing everything off and doing that. So it is a path that can be done if you really want to get an idea about how leaky the house is. And you can also put it on the return because again, anything moving through the system is moving through that path and trying to find a way to the outside. Again, this is also if your ducts are in and outside type of conditions. But if your ducts are inside, any kind of flow would mean that there actually must be leaving the area that you're pressurizing. So if I'm pressurizing this area and the ducts were inside conditioned space, any leakage is telling you that you actually have a path where they're at that leaks to the outside. All right, any questions on that method? Okay, so the other one I want to talk about is you can still do zonal pressure when you're doing pressurizing the house, okay? So I did not flip the fan around on the illustration, but we're just going to assume that we did. So if I'm pressurizing the house, again, it's the same concept of how I would set up and run a zonal pressure diagnostics between what are my connections between the inside of the house and the attic or garage or the crawl space, anywhere where I know is considered to be unconditioned outside the thermal envelope or outside the air barrier, I can find out what are the connections that are happening with that. So again, your numbers, instead of being a positive number, or they're now going to be a negative number, but they have the same representation. So the attic should be negative 50 if I'm running the depressurizing to 50 pascals. I'm going to get a number that says negative 50. So here I've got 35, so that means I must have some kind of connections through the house. And now it's a matter of actually going around and either using your smoke, which is no longer going to be puffing at you, it's going to be blowing through. So you actually can watch the air move into the structure versus kind of coming out of the structure. Hopefully that was clear in terms of, again, another test you can still be doing. So in this situation, the basement is part of, somebody asks, is the basement conditioned or not? So in here, we're going to assume that it is a conditioned area, especially because we're going to assume that the walls were insulated, to clarify, and my ducts are down in that area, so that would be a conditioned area. Okay, so let's talk about testing exhaust fans. I know we've done many of webinars on this. We're going to have another one coming up in next month. It's about the installation and confirming their installation that goes along with ERVs and HRVs. We're working with, going to reach out to a couple of manufacturers to help us with that webinar. So one of the things that's different about this is, again, this is the Energy Conservatory exhaust fan flow meter box. It's very common. Many of you, if you have one of these, that's great. You can also make your own out of cardboard. We're going to go through some of those. But measuring the exhaust fans is really a crucial element to doing diagnostics on the house. Many of you do that, but you may find out that it's 35 and the homeowner doesn't want to do anything about it. But if they have issues with moisture, now I know this issue, and now I can actually address it with them as to what else they can be doing to reduce their moisture conditions that they're having in the house as one source. So the one difference is that if you're going to use the exhaust fan flow meter with the Energy Conservatory, the instructions state to connect it to the input, all right, and that's very common. And then people then trying to do that with the Retrotec, and it doesn't work. You're actually going to connect it to the reference, and you'll get the same readings as you would as if you use the Energy Conservatory gauge. So it kind of looks something like this. And one of the things that we recommend is that you actually tee together, whether you use Energy Conservatory DG700 or you use the Retrotec, is you tee the results together. So that my reference is where I'm going to get my CFM results from. But I also should be keeping track of the pressure, because the guidance is that you should make sure you have at least 1 Pascal of a reading and nothing more than 8 pascals Otherwise, you've exceeded the requirements for the exhaust fan flow meter box itself. So if you just do it and have one tube that goes to the reference on channel B and I get my result, I may not know if I've exceeded or didn't get enough pressure on channel A. So no matter what gauge you use, this is the best method to confirm I'm within my 1 to 8 Pascal range to get my results. And basically this is just how, the same way you use a blower door or a duct tester, that the exhaust fan flow meter just has or different ways of opening or closing it, same way you add ranges on your blower door. So it's the same concept, but now I want to make sure that I'm in the test parameters for that. So that's kind of what it looks like if you're going to use the Retrotec gauge. And there is information in the duct tester manual that you can find online under support, and it shows you how you can make your own box. In fact, this box I made, I would actually have put an opening that's a little larger, somewhere between 4 by 5, 3 by 6, somewhere in there. You can also tape it back down if you're not getting those pressures. The difference here is that I don't need to be between 1 and 8. I do recommend that you have at least 1 Pascal, if not 2, is your pressure, but I'm not limited by 8 Pascals anymore to do this reading according to the instructions that are here. So again, you can buy one or you can make your own. Some people go to the Container Store, and the common hole may be able to be used for many of your readings. Or again, you can just tape it off, and the exhaust hole flow meter is in the gauge, and this allows me to use any kind of box with any kind of opening, and it'll tell me how many CFM are moving through whatever size hole I've got. So it's different from actually using the exhaust fan flow meter where I actually have this device selected. Here I'm actually going to use an app that's inside of the gauge itself that allows me to use any kind of device. And where that becomes really a phenomenal resource is when I've got an exhaust fan in the kitchen that is not easily measured based upon its shape, its size, or its location, that I can actually create a cardboard box or some kind of enclosure and set up a thing where I have a static pressure probe in the corner. All the instructions on the thing describe this, and I can now do this. So most people that are in IAQ understand that there's a new relationship with the kitchen and exhaust, and that is that besides your garage, if we're talking about the interior, the one place that has the most contaminants is your kitchen. That's where we store a lot of our cleaning agents under the sink. That's where a lot of the grease and the food and all the other stuff that's the high particulate, high impact for IAQ is in the kitchen. So that this exhaust system must work well, and many of the new manufacturers are installing this low CFM and able to do the compliance for 62.2 in the kitchen, because it's the one place, if you're going to have a little bit of constant flow, it is best to have it in the kitchen in terms of removing particulates and other issues. Okay, Jay, you want to read what Michael Dunseth said about the system here? You want to read that?
Sure. Should I read it in Michael Dunseth's New York accent, or should I just do it straight?
No, you just do it straight, because not everybody knows Michael. There's a few people out there.
Yeah, plus I'd probably have to use some cuss words. Yeah, he says, please don't use cardboard. Buy a plastic tub like a Rubbermaid, and then add a thin peel and stick weather strip around the outside. Cardboard works, but it's hard to charge good money with that. I'm sorry. So yeah, so Mike says basically cardboard works great, but it doesn't look great. So it's hard to get somebody to hand over a fistful of cash when you're testing with a piece of cardboard. Good. Thanks, Mike.
Great. So yeah, that's good advice. Okay, so here's the basic setup that we show it in its full glory right there. Okay, if you're using the, so I got some other examples of measuring kitchen exhaust dealing with the microwave. The microwave can be a major challenge to measure this. In fact, here's my question. I got another question for everybody. How many of you measure kitchen exhaust fan flows in terms of, their max CFM and whether they're reaching 100 or not? So it's really common for people out there to do the bathrooms. It's an easy access point. And of course, Michael Dunseth says he does. So, but the rest of you, anybody out there, I do or I do not measure the exhaust fan in the kitchen, just kind of gives us an idea about, well, yes, we're doing it, and if so, what are some of your methods that are out there? So the microwave is a challenge because this is one fan with 2 inlets. Other exhaust fans have a much larger opening, and it's hard to actually enclose that. Some people have modified their own little makeshift thing. This is the thing that I have made. So the opening for most microwaves is very common. This is a 1 foot deep by just under 30 inches wide type of a device. And I changed it, instead of having a circle here, that it actually is a square. So I can tape it down and use it with the gauge itself. I can use it with a duct tester. I can use it with the Retrotec's power flow hood, or you can use it with the Energy Conservatory exhaust fan flow meter. So something that actually controls the flow through a single source is a simple solution that's out there. So this was just made out of a 1 inch 3/4 foam board, and just taped together with a static pressure probe in the corner. You can see the static pressure probe here. So you can also use your duct tester as a power matching flow hood, or an actual flow hood, or you can use the gauge itself. When I know I have a known opening here, I can actually use the gauge and use the whole flow as an actual way of measuring these. So there's a lot of things that are coming of age to allow you to do this type of a system. And you can see it there in place. Okay, so let's move on to some other questions that we got out there. So one of the ones that somebody did ask about, what's a dominant duct leakage test? Some people are familiar with, so let me ask you, how many people do a dominant duct leakage test? And I'll explain that we're on the same page. So you basically, there's no blower door here. This is just, I have my gauge, it's turned on, and I'm using the one tube that goes to the reference on channel A, and it goes outside, and I turn on the air handler. Normal operating conditions. A house is sealed up, obviously, so I have the house sealed up so I can control the environment, turn on the air handler, and want to find out if I'm going positive, basically, or negative, or how high of a number do I go. A lot of times this number is very small, like 2 pascals. It's rare that I get anything really over 5 pascals. So, but a couple pascals is a number worth reading and paying attention to. And this is relating to your duct leakage. So if anybody out there is doing that, then it's a simple test to find out, is my leakage more return or is it supply? So again, it just the gauge, just the air handler, and I'm actually, the input is now on the inside of the house, and it's open, and I'm referencing with the reference side to the outside. It's the only time when you do these kind of diagnostics that I actually switch the tube. Almost everything else we do, our tubes are on the input side here. So again, it's one way to remember the dominant duct leakage is I want to compare the inside and referencing the outside. And here's one of the reasons why you measure that, is because duct leakage has a significant impact on our home. So supply leakage sucks. They both begin with S. It's an easy way to keep track of it. But let's assume that my arrows that I use in my illustration are an equal number of CFM. So let's say that these are each 500 CFM in our system. So if I'm losing 500 CFM, my motor is going to keep turning and making sure that I keep returning the same amount that it should have in the motor. So it's going to find it from someplace else. So if my number that I did on the previous test was negative, I know that my supply leakage is the more dominant leakage of the two. Right? So the other one is return. Obviously it's the same. So if I was positive on my previous test, then I would kind of get a positive pressure on that test. Just because you don't get a dominant leakage doesn't mean there's no leakage. It just means your leakage is equal between supply and return. Another thing that's common in the people that are doing home assessments that are not energy related but are more IAQ is many of them do measure the supply air and want to find out if they have any kind of restrictions. So they'll try and do a quick analysis of how many CFM are they getting out of all the registers throughout the house. So that can actually create issues. We know that this is an impact of comfort, but also can be an impact in terms of other issues in the house. So it's not uncommon for IAQ specialists to actually do a measure of supply air. And at that point, you can use a non-powered flow hood, a passive flow hood. But sometimes you want to make sure that the better ones do the best, and they actually can be kind of bulky. But in general, any flow hood, any measurement is better than no measurement. Let's make sure we're clear. But we, of course, want to promote that this device here is even a little cheaper than the high-end passive flow hood, and measures flows down to 6 CFM. So it's a phenomenal way to balance a system or get great measurements out of some of your supply. Okay, any other questions about the testing side before I freak you out on the issues you're going to find in your house? So anything else, Jay, that you want to touch on real quick?
Uh,
Someone said they've seen 10 pascals on their dominant duct leakage. That's pretty significant.
Joe, are we going to talk a little bit about potential structural issues?
I don't. Let me clarify two things. So I did not. That's something that we could try and create a discussion about. When you're dealing with IAQ, which is a strange concept for me because I didn't come in it from that perspective. I came in it from energy and home performance and house as a system. That things that occur in the attic and occur in the crawl space. Let's say that you go in an attic and it's covered in mold. For IAQ specialists, they don't care about that because it's not part of, to them, it's not part of the indoor environment. So they're like, well, you actually have potential mold up in your attic, or you have some kind of fungal growth that's deteriorating your structure. But to them, they don't consider that there's an impact on the inside. They also don't think that there's a large connection between the inside of the house, the interior, and the attic, or the crawl space and the inside. And we all know that that's not the case. But to them, they're like, well, that's in the crawl space. That's not up here. It's not something I think you should be too concerned about. It's only a condition of the structure. It's a structural defect. So that's why the Healthy Home Evaluator is going to be incredibly valuable criteria in way that we're going to change the way we all do audits in general. That there are these things that we actually weren't as hypersensitive to, and we're going to enlighten the other side of the world that yes, your attic is connected and so is your crawl space, and those are the kind of things that need to be tested and confirmed. So was there specific questions you found about dealing with the structure that we want to address, Jay?
Just the fact that when people see a drop ceiling in a building, are you going to mention anything about that?
Go ahead.
Oh, just a note that when you see a drop ceiling, there's a reason. So a drop ceiling or a faux ceiling is usually a ceiling that's suspended, um, and it's not the actual original ceiling, and it's almost always there because it's hiding something, whether it be some kind of damage or that was caused on accident, like something, water damage or something like that, or damage that was caused by people perhaps running electrical conduit or something like that. But point is that if you're depressurizing, you need to be careful and always open up at least one tile and look behind it and leave that tile open, because what can happen sometimes is that you can move so much air from the space behind, which is usually an attic. You can move so much air through that space behind that suspended ceiling that you can actually cause damage and sometimes even make it fall down. That's all I wanted to mention.
That's good. That's good notes. And and one thing I didn't really make stress of, if you're going to test anything, in fact, it was actually a recommendation from for the code hearings are happening right now for 2018, and Robbie from Energy Logic requested that the garage be confirmed that it's not connected to the interior. Of course, they denied that as a code compliance. But it is, if you're going to confirm one place and you're dealing with people that may have sensitive issues or suspect conditions, it's confirmed that the garage is not well connected. Like we talked about doing the attic or the crawl spaces, that the garage is it's the most highest impact of potential carbon monoxide or contaminants. So you definitely want to make sure you're checking that. And again, you can do that under pressurization. You can also just do that in terms of, is there a static pressure that's happening when the home's in a normal condition. All right, so the next series of slides are all going to go through a very brief overview about contaminants and what they are and how you should think about them. And I cannot tell you that you can identify them. I can tell you what you should never say. But again, these things are exist and can be hidden. And one of the things that I miss about going to homes every day like I used to and doing home inspections, energy audits, is going to older homes and trying to piece together what was the history of this house and when did this drop ceiling get put in and when did this change, and suddenly there was a wall here and it's gone. So I kind of miss that. But when you're there, you want to kind of make sure you're evaluating some of that stuff. So these older homes that have these kind of conditions usually have some other history that's going along with this, or what's here that should have been here that's not, is the one thing you're really trying to keep in the back of your mind. So lead, as you probably read this, is the word plumbing comes from the Latin word lead. And there's a shocking slide next, which is that in 1980, we were testing the blood levels in children and adults and found out that the amount of lead that Americans were ingesting was over 5,000 grams per year. And this is based upon a lot of things, that not just lead paint or other things like that, but just lead was a common thing that was in a variety of products. So, and we all have heard the conditions that Rome fell because everybody was eating off of lead plates and using utensils and lead piping, but that was only a tenth of what they had found approximately in the Romans were using. So there was an enormous amount of lead issues in the U.S. until the EPA got more involved. And after that, it actually reduced due to a variety of other issues. And then it wasn't until recently that it really came into forefront in terms of how we evaluate a home that may have these lead conditions. So again, you've probably seen this slide. 1978 is the trigger when it was actually then saying that, you know what, lead was no longer allowed in paint. But many manufacturers caught on to this and weren't going to wait till the last minute. But in general, 1978 is the rule. That's the legal law in dealing with real estate and other transactions. So I just kind of keep it in mind that there could have been other conditions that were around maybe as a few years after that you're still kind of sensitive to, that maybe in 1979 that still may have had some paint sitting around at a warehouse. So yeah, oops. So how many people out there are lead safe certified? So that actually kind of gives me an idea about how many folks are out there who have taken this. I took it a couple years ago. I have not renewed yet. It's one of those things where you want to, I got into it so I would understand the knowledge level, but I'm not in the industry enough to feel that I need to keep maintaining some of my certifications, but I understand the sensitivities to them. So some of the places that are key to addressing lead, in fact, I did a thing for BPI recently about evaluating. If you ever go to a kitchen and they go, oh yeah, we recycled these cabinets from my grandmother's house or from an old home, there should be a trigger that goes off in your head knowing that, holy cow, I bet this set of cabinets had lead paint on it. So, and again, cabinets are a major source of flaking paint. Things that move or are getting bumped are a source of flaking paint. So it doesn't mean they had to have been stripped or removed, but you want to make sure that there's no issues with, again, paint flaking off or having other kind of conditions. So one of the issues that I also wanted to bring up is how are people dealing with lead paint that's clearly on the outside of the house? There probably is, and again, this is just my opinion as Joe Medosh, there probably is a low risk that it may be brought into the house for a blower door, but that's something that I would not actually be addressing or want to find out the hard way that I had done that somehow there was some large cracks underneath the threshold, and somehow I'd introduced a bunch of nasty, paint debris, dust to brought into the house. So these are the reasons why you decide to turn the fan around and just pressurize to neutralize any kind of contaminants being brought into the house, and make sure that in front of the blower door isn't a bunch of other issues that go along with that. It's also not the pollen season. If you have people who have allergies, last thing you want to do is on a high pollen day do a blower door that pressurizes the house. All right. So my one other question was to kind of explain that is that the blue door I have could be an interior door, or it could actually be an exterior door. So those are the kind of decisions you make in terms of whether or not you're going to, again, pressurize or depressurize or be more sensitive to how you handle these. Having a system in place that makes you determine that when I see this outside, this is our course of action for you or your company, helps your liability in terms of when you show up that you already had a plan in place. Let's move on to asbestos. I have a lot of slides on asbestos in terms of things. So one of the things is that most people understand that it's a natural occurring fiber that's around other parts of the country. It's highly likely that you could ingest between 10,000 to 15,000 fibers a day. And there's different types of asbestos. I did do a webinar with Efficiency First about asbestos. You can go and look that up and see the webinar that we did. But in general, asbestos has different things that are going to affect or impact how we handle the house when we see it in certain areas. So one of the things was, how do you handle it and you don't? What do you do if you suspect it? My goal here is that, again, you're the auditor, you're a home performance HVAC contractor, and you're going to see, again, a variety of these things. So the one thing I want to keep on this slide was at the bottom, so you understood why asbestos was it was one of the first miracle products that the world actually had found. It was a natural fiber, and the Greek word means inextinguishable, that it was such an amazing fire retardant that many of the rich had used it for tablecloths and other things, because if the candle fell over, it would not catch on fire. So there's lots of other verbiage in a variety of texts, all alluding back to the Egyptians and the Greeks about why they thought this was such an amazing fiber to build certain types of materials out of. I'm not going to go deep into this, but I do want to make sure that you do know that there's lots of studies that have been done about asbestos versus fiberglass. And the difference is that they both are irritants. Nobody's denying that fiberglass, the breathing a bunch of fiberglass is healthy, that they both are an irritant and described in that kind of way. The difference is that what they discovered is what the fibers that are from asbestos can actually get into the lungs and cause irritation that can actually lead to cancerous conditions. The fibers that can get into your lungs from fiberglass were able to be digested by your lungs, and that's kind of from the research that I found. I don't have the exact source, but I could find that if you needed it. But that's kind of the general understanding in the IAQ industry, is why they're both irritants, but one actually has been considered a carcinogenic. So again, asbestos has been around and been noted in many of documents since 5000 BC, and it was commonly used in a lot of stuff. It was like the miracle thing in this last century in terms of for firefighters, for people in industry, shipbuilding, a lot of stuff. And in 1989, it was banned, and it was banned pretty much worldwide. Most of the world got on the thing, said, that's it, no longer can you make products. The industry fought back, and the EPA ban was overturned in Congress in 1991. So the U.S. is still one of the only few countries that allows asbestos to be used in a variety of products. And here they are. So these are the kind of stuff that is in many of the stuff that we still go into older homes, or some newer homes are still allowed to have this. I don't know the actual percentage, so if you look at the bottom under vinyl floor tile, I know that that was a significant issue. Jay has a story, which we don't have time for today, that he had that at his home, and but there's a variety of stuff out there, and it's still allowed to be used in certain conditions in certain areas. I know that brakes are the #1 places where you can find them today, as well as some other areas. So I just want to make sure you're aware of that. So these are the top places where we find it in our lives in terms of doing energy audits. Pipe wrap, the heating duct wrap, the ceiling tiles, the popcorn spray, the floor tiles, which are defined by 9 inches by 9 inches, and vermiculite insulation. So if you're seeing any of these, then it's your goal to make decisions about what kind of testing will you do and how much will it impact the movement or issues on here. And based on all the things that are on here, it's only the top 2 or the bottom one that actually will really become a concern for you. Unless you have to move any of these things. I would not be taking ceiling tiles out to look above them if I suspected they were asbestos. So, but vermiculite insulation is a common one that is in the attic, and whether you decide to do a blower door test at all is your decision. So even if you pressurize, doesn't mean that you may not stir up some debris on these large openings around electrical fixtures that could still allow stuff to fall back in. Pipe wrap, that's in heating duct wrap, those are kind of things that you can decide on whether you're still going to do your duct test. Again, the other option was to find out if I'm just going to use a flow hood to find out what kind of leakage they might have while pressurizing the house. So here's a vermiculite ceiling, and there's again, the EPA has got an enormous amount of information about this and what they recommend in terms of doing that. There's also some funds to help people get this stuff removed. So now what do you do if you suspect that you have asbestos? Again, you're going to start with, what's the material, where is it friable? I have a definition of what friable is, and is it going to be disturbed? That's really your thing that you need to decide. Talk about it with your clients. Make sure that you're making an informed decision and you're keeping your clients in that decision-making process. So even if you decide, I'm not going to test this, and they decide they want to have somebody else do it, that they feel they were informed as to why or what the risks are. So again, education is the key to reducing or eliminating your liability. So you know, do you have the resources that you're going to send to them? Again, the EPA is full of them. This is where the ASTDR comes into play in terms of their resources with a variety of these types of contaminants, as well as CDC. So here's your definition of friable, and you can read whether or not it has a percentage of asbestos in it when it gets sampled, but the reality is that will it be crumbled, pulverized, or reduced, or come loose by the pressure of an ordinary human hand? I know that's a vague description, but the reality is if I were to touch it, can I see fibers or see it becoming loose? And that condition is, it is considered friable. And let's say you're doing an HVAC system and you come out to do the duct test to find out, like, oh, we're going to find out if you need to replace your system, or they find out that it has asbestos. That you want to make sure they're aware that this could be, and it can be tested. It's a very cheap test to do. But if they're going to replace any duct system that has this on it, then that should be handled in a specific way. And a lot of HVAC contractors are very sensitive to this and know how to do that. So letting anybody grab a bunch of stuff that could be in their attic, or some of it may be in their basement where they actually have other belongings, that the last thing you want is somebody who doesn't know what they're doing to pull this stuff apart and send these fibers throughout other areas of the house or against their the articles that they may have in the area. Okay, how about mold? All right, so we're approaching our time frame at this. I only have a few slides left on mold and a reminder about what you should do. So mold is everywhere. It's been everywhere. It was here clearly longer than us. I've worked with many people who are incredibly hypersensitive to mold or fungi growth, and I've worked with people that can eat it, rub it on their body, and it doesn't make any impact on them. So I'm not here to tell you, you know, how you live your life with or without mold. That's up to you. But in terms of our testing things, here's one reference that it's in the Bible. So next time you go to church, you can look up Leviticus chapter 14, verse 34 and 47. It clearly describes what is mold growing inside the house. It says to remove it. Of course, get your priest, because he's the expert on this. That's your IAQ specialist. He'll just tell you to scrape it off and remove it. If it comes back, then take out that part of the wall and fix the wall. If it comes back a third time, just tear the whole house down and take it someplace else and put it into the heap pile. So not much has changed since this was written, however many thousands of years ago. So we still have somebody do a specialist. They clean it up, and if it comes back, then they should have fixed it already. They take out that area. We don't tear down the house anymore. Yeah, Jay. Oh, sorry, that's my sound on my thing, sorry. I thought that was Jay in the background trying to say something. So I did that slide trying to show you how easy it is that things that are light can move around the house. The most common issue I've found with mold is people are like, it's okay, it's all dried up. It's on the wall, but it's dried. And that actually is the worst case scenario. The best thing for it to be is actually moist and wet and happy. I mean, it's not looking for to go find another food source, which is its moisture source also. So if it's dried up, that means it can easily aerosolize and move throughout your house. The other one, people is like, well, I poured bleach on it, it is now dead. And FYI, the dormant, or what you may call dead, still has mycotoxins. The things that make us allergic to mold are the things that are in the mold, not that it's alive or dead. So do not make the assumptions of, you know, oh, it's okay, it's dried up, or these other things like, oh, they poured bleach on it, or some of these mold fungi killer things you can buy. Mold should be removed from the structure in any possible way and means. The last thing you can do is encapsulate it because you really couldn't remove it. So there's an enormous amount of protocols all on this. EPA has basic guidelines for the average homeowner to do. The one thing that I would encourage you is you go to a bathroom, that there's a difference between what's considered hygiene and damage. When I have water running through the wall and I have a mushy surface that's clearly covered in some fungi growth, that's a problem. Having mold grow on the surface of a wall that could be really cleaned up with soap and water, the EPA has guidelines on that. So you can easily find, they describe it as 10 square feet. You can clean it up with soap and water by an average homeowner. And don't confuse hygiene with actual water damage. Those are two different things that kind of get messy in our industry, that you can apply some common sense, like, wow, this clearly it's in the kitchen on the back wall, and there's no damage to the surface. You know, this is something that the EPA says you can clean it up with soap and water, here's the reference, and let them take care of that without freaking everybody out that they got something fuzzy on their wall. I'll do briefly here that this woman had a 10,000 square foot mansion. She was an executive in the industry for advertisement, and her house became a mold nightmare. And she ultimately sued and won for millions and millions of dollars. And she was the first case that brought mold into our reality in terms of why it was such a big issue. And then after that, insurance companies were paying out for mold damage, and they got burned. People were spraying their house with a faucet or a hose, leaving for vacation, coming back and get their whole interior replaced. So industry's got wise to this. So some of the resources for mold, and there's the EPA handbook that you can download or access on their website on mold and what to do with mold. So one of the things I do want to make sure it's clear, and I'll see if it's on the next slide. Yeah, so these are some IAQ issues that are come with that, but only a certified person in mold who sends a sample to a lab, you can rephrase that, anybody who's trained to take a surface sample or send in an air sample to a accredited lab can actually determine if it's mold or not. So it is right in the screen. I'm looking at the icons. So you do never want to exceed your credentials by stating that it's mold. In fact, you can't say that. Even if you have the credentials for being a mold certified individual, you would then know you can't say it's mold. You can say that which resembles mold is some type of fungal growth, but until the lab says what it is, there's nothing you can say. Should address it as a moisture issue is really where your focus is. So these are some other IAQ common things that you can get from the EPA, and dog dander, cat dander, old carpets are just the worst thing that can happen in a home. Cockroach droppings, it isn't really the roaches, it's actually their droppings. Same with cat and dog, it isn't them or their hair, it's actually their saliva that is on the hair that becomes the triggers for these kinds of issues with asthma. Dust mites, and of course the mold issue. So all these are common things that can trigger asthma throughout the house. So the last thing you want to do is do a blower door or some kind of performance testing that can actually stir this stuff up, even though it may be dormant in that house right now. This is what an air sample may look like, and the amount of stuff that your air sample for a mold professional would grab, and they actually evaluate the stuff on a much amazing scene that we would never even think twice about the kind of stuff that's in our air that we're breathing all the time. Rodents are a common issue. Again, these are kind of things that you suspect them, then you want to be careful about whether or not you're going to be bringing these contaminants in. Mice urine or rat urine actually has the ability to deteriorate their old carcasses, so they can use them kind of as a nesting concept. So that's one of the issues with having rodents inside your walls. And this is my last slide, and I grayed out the bottom because it's information. I didn't have time to update it, but this is still a common fact that 2 to 4 people die each day from asthma. That they have an asthma attack and they either went to the hospital or couldn't get to the hospital, and that was their last day. And the reason I try and make this my last slide is because the last thing you want to do when you go into a home is trigger an asthma attack for those occupants. So that's why it's so crucial that you ask those kind of questions about what kind of breathing disorders or conditions they might have, and be selective about what kind of things you're going to do to disturb their house, even including how you go from the crawl space to the attic, and when you do that, and when you come back into the house. You know, where do you take your coveralls off? All those kind of things can be the small things that can trigger an asthma attack. So that's why these subtle little micro conditions in the house can be a major significant issue for others. So this is the last slide here, is would you perform a blower door or duct test based upon what you see here? And you're welcome to chime in, that's up to you, but the reality is that you should just have that down as a knowledge base, and even try and document your own decision before you get stuck in the house trying to make that decision. So there's a lot of information, you'll be overloaded on the information. EPA is a great place to kind of move through their documentation, to have stuff to send to the homeowner or educate yourself, to be honest. So I got a couple questions here we're reading over to see. Hopefully you found this information informative. I describe this when I do it live as IAQ, what you don't know can't do. And most of this is based upon a knowledge level. So hopefully I encourage you enough to go find out more information and make the proper decisions about what you do in a house. And maybe you go to a house and nobody's home, or you don't have the information that you needed. So make sure you're very aware of the conditions from the homeowner that are not always just the issues with the condition of the house itself. Oh, asbestos-like materials. So because I did some training and I tried to make a determination whether it was friable. If I saw something that was wrapped in an older set of ducts, I personally would choose not to test them. That's my Joe Medosh decision that I made for my business because I didn't think that it was worth those kinds of risks. I also know that it's very easy to take a small sample of it and send it to a lab and get your results for less than usually $20. So there's ways to find that out and relieve the concern that other your homeowners may have about what it is, or can you come back and do the duct test after you find out what those are. But again, I got trained on how to make sure you took a sample and where to send it to. So all those things are actually easily done, and many of them will be part of the training for the healthy home evaluators, how to take common samples that are considered to be non-invasive. Steve asked about, you're looking for asbestos info, not mold info. Was there something else you're looking for? I know that there again, you can do a Google search to find this stuff, and you can feel overwhelmed. But if you stick with a few of the power players, EPA and CDC, you can find a lot of what you're looking for. Any other questions that are out there? Hopefully this was informative and not confusing, so you can understand some of your testing options. We'll probably be coming back in about 2 months with a Healthy Home Evaluator a testing protocol, which includes a few more other things that actually will accent the training for the Healthy Home Evaluator on other stuff, and including our goal is to do things that deal with maybe kind of surface sampling or other stuff. And the reality is it doesn't really come into play with Retrotec's equipment, but the owner, Colin Gange, is very involved with healthy homes, and it has been his passion since he began the business. So he feels it's a great topic, even though it has nothing to do with using a duct tester or blower door, that he wants the industry to feel informed, and this is one great way to do that. Any other last call for last questions? Jay, anything else you think we need to add to it?
No, I think it sounds great. It's getting a lot of really good feedback in the background, so I think that we can move out and say thank you so much. Joe, you want to take us out?
Yeah, I know that Todd and look at maybe a few others were asking about, we've been mentioning that we're going to do a large, we're going to test a monastery in New York. So the reality is we're a part of a group that's doing that. So I know Todd asked about it, and Jay will grab your email. If anybody else is interested in it, just toss your name out real quick, and we can send you the details. So it isn't something we're actually hosting, but we're a part of. We've been mentioning it, so we'll probably be sending out an email by this weekend, kind of giving the descriptions and where it is and what it is. And we're basically going to test a large monastery over the course of 2 days, from IR, blower door, doing guarded or neutral pressure tests, and a variety of stuff. So if you're interested in that, shoot us a line, and we'll make sure we include you in our feedback. All right, everybody, I'm going to call it a day, and we look forward to seeing you at our next webinar. Thanks a lot, everybody. Take care.